And we are now recording.
All right. Well, hopefully everybody enjoyed lunch. We've got Deral Heiland, who started this group 7 years ago now, I believe. He's got a face made for podcasts, and his mustache launched the hipster revolution. So he apologizes for that, as we all do.
He was the first.
Yeah, he was the first. It's a horrible
He
trend.
did it before it's cool.
It's yeah, it's not good, but not everybody can get everything right. So we allot that to Deral. That's his one mistake so far. But we are thankful to have him speak, and he's going to do some cool stuff and talk about some of the changes for Praeda, which is going to be pretty exciting. So I'll turn it over to him.
Thank you. Let me turn this on. So did everyone hear me flush the toilet? That. Can you hear me? Is that working now? Yeah. I apologize right now to Adrian that he'll probably not keep that camera on me because he's recorded me before and I have a tendency to get very mobile. So my presentation is, Praeda to PraedaSploit. Embedded device hacking for the masses. So, been really busy lately. Been traveling a lot. So there's not a whole lot of slides in here. There's a few. There's not a whole lot of slides. But so what I want to do is I want to talk to you about, and I think most of you are probably aware of some of the work I've done over the last couple of years, specifically with printers. Everyone associates me with hacking printers. Even though I do other cool things every year, the printer thing just doesn't go away because it's a valid attack vector for pen testers. Typically, you can go into a company, and if it's a large company, let's say 1,000 employees or so or more, we have a hit ratio of between 40 and 50% that we can extract Active Directory credentials from a printer and gain access and a foothold into the environment's Active Directory. So we've been playing with that for a number of years. I think we started 4 or 5 years ago doing that, and back then the success rate was probably 10, maybe 15%. Since then it's up to, like I said, 40 to 50%. So I worked for Rapid7, a little bit of history about me. Before that I worked for CDW, but I'm working for Rapid7 as a pen tester. I'm on the pen testing team. I've been in IT for 20 plus years. We'll just leave the plus there. I'll never change that number, it'll always be plus. And yes, I've been shaving my head for 30 years, so I've been shaving my head from the time I actually had hair on my head to shave. I don't have to quite shave it as much anymore. It's kind of caught up through attrition. And I've been working as a pen tester for the last 6 years. So let's kind of dig into this. So what are we going to talk about? So we're going to talk a little bit about Praeda. We may not even run the full hour. I'm not sure how this will go. It really comes down to if you guys start falling asleep on me or show no interest, I'll just talk quicker so that we can like eat free cake. So we're talking about Praeda, using Praeda. It'd be nice to be able to do live examples here, but you know I'm not going to commit a felony on a phone or on camera, so we're not going to do this a demo of the tool. We'll play with the tool. I'll show you the functions of the tool, and then we'll move on from there. And then we'll talk real quick about PraedaSploit, what we're doing with Praeda, and what we're going to move Praeda to next. Then we're going to talk about migrating Praeda over to Metasploit. And then we're going to finish up with the future of PraedaSploit, how we're going to interact. Hopefully, we haven't done it yet. It's still in the design stage of the new Praeda, the data embedded device harvesting data tool. How's it going to interact with Metasploit? Yes?
Just a quick question before you go on.
Mm-hmm.
Is Praeda now a Rapid7 tool, or is it still your personal project?
That's my personal project.
Okay.
So that doesn't change. This is something I developed 4 years ago, and I've continued to support it. And we'll continue to support it all the way through until the new version comes out, which we're going to move some of the functionality over to Metasploit, and I'll explain why we're going to do that. And it makes a lot of sense. So let's go ahead and move from there, see what the next slide says. Okay, so it looks like we're going to talk about Praeda. Yeah, I was like 3 hours sleep last night, and I kind of finished organizing the slides, so I'm never quite sure what's going to show up behind me. Hopefully nothing's going to give you trouble. So what is Praeda? Praeda is the name of my tool that I developed 4 years ago. It's Latin for plunder, thief, booty. So basically it's the word for robbing somebody freaking blind. So the current version is written in Perl. And let's like level set this whole thing. I am not a programmer. Okay, so writing this whole program, and it progressed quite a bit over the years and gotten fairly advanced, was not necessarily easy for me. I'm not fast, I'm not proficient, but I am stubborn. So I can normally get things working, and when they don't work right, I can usually figure out how to fix them. If you sat down and said, Deral, right now, write me a program in Perl that'll print hello world to the screen, I will give you a look of total befuddlement, okay? And then I'll jump on Google and figure it out. So that's my programming skills. And I'm good at that. I'm good at Google, okay? At least I think I am. Okay, so current version of Praeda will actually enumerate about 103 different devices or models. So as an example, if we're looking at a Konica printer or a Xerox printer, there's multiple models. So we have various changes within the application and stuff. It'll test for various versions, and it'll check for all these. And it's about 103 different devices. And it covers things from network cameras to multifunction printers to switches, load balancers, modems. I mean, there's all kinds of things we look at. What the tool will harvest. It will harvest Active Directory credentials. It'll harvest usernames. It'll harvest SNMP community strings. In some rare cases, it'll actually kick off the scan bed on a printer, especially the smaller ones that we find in offices. Like the office, you know, the cheap crap $150 office jets that everyone buys for their homes. Well, I find companies buying those and executives sticking them in their office so they can be printing, scanning, do all this stuff. And they don't have to get up and walk 30 feet to a freaking printer, okay? So they're lazy. They're also lazy at leaving stuff sitting on the scan beds. So in Praeda, even if the printer is secured, Praeda will actually, on a number of these office jets, trigger, in spite of the security, the scan bed automatically and send me what's sitting on the scan bed. So I threw that in there purely as just something fun and evil to do. It rarely adds much value during pen testing other than to make fun of somebody that they put their, you know, their paycheck or something on there, or left their driver's license in. One of the cool demos is I actually demoed Praeda in Norway a number of years ago, and I was thinking, okay, I want to demo the tool somehow, but I don't have access to $10,000, $12,000 printers to do this. So I set my office jet up home and put it on the internet. And I was thinking, well, what can I show them that would get their attention? I'm thinking, I don't think they'll get this, but I'm going to do it anyways. I actually put President Obama's birth certificate on my scan bed and then attacked it from Norway. And was actually, and I'm waiting to see what's happened, because when you're in foreign countries and speaking, you don't know the culture, or even if they could get stuff. And believe it or not, they actually got it, so that was somewhat entertaining. I think one time at a conference, I dummied up the conference. The guy who was running the conference and was the MC, I dummied up a credit card, his credit card, the fake number and everything, and put it on the scan bed, and it's running, shows up on the screen. So that's one of the ways I've demoed this tool. So there's all kinds of functions and features, and we'll look at some of these, and we're going to look at some of the outputs of these. And the way we fingerprint with Praeda, there's a couple things we do. I don't think this point works. Let's see if this works. Ah, dang, man, that's not bright enough. Oh, we can barely see it. My battery's going dead. Anyone have a couple AAA batteries on them?
Looks pretty good.
Yeah, you'd be surprised. This will light up the entire room.
So is the screen, the red one.
Well, it'll absorb some of it, so it's getting brighter. As this thing heats up, it gets brighter. So the way we fingerprint devices, there's several key pieces of information. So what Praeda does is it enumerates several things. It queries the web interface on devices, because we all know, or we should all know, that all all devices in the world have web servers. I don't know if you think this, but I really don't think that was a really brilliant idea to be thought out. But it makes my job fairly easy. So this tool will actually query the web interface. And what it looks for is two pieces of information, the title page and the server type. We find out probably in about 75% of all occurrences, the data returned helps us fingerprint the device down to, sometimes all the way down to a model number. We can identify the web server, the title page as two pieces of information, and we're able to quickly see, hey, this is a Cisco device. This is a, there you go, much brighter. So this is, a Xerox printer. It happens to be a Workcentra 5640. We can get all that kind of detail about 75% of the time through that. Then we also found out for most devices, mainly printers, SNMP. Now, of course, SNMP we know is enabled on every freaking thing on the face of the earth, right along with web stuff. So the SNMP stuff, we found out for fingerprinting devices comes in handy on printers especially, because printers, SNMP is going to be enabled. You're not going to change it, so you're not going to change the public community string, because what happens if you do? Basically, the functionality of the printer breaks. So your printer driver can no longer tell whether the printer's out of paper, out of ink, all those fun things. So that's never going to change. Now, SNMP across other devices, we gather that also if public or private is actually enabled. Mainly public, I think that's what we check for. But in a lot of cases, I want it if it's changed. So we have a lot of attack modules in there that'll hit the interface, identify the device, and then what it'll do is it'll log onto the device, go to the configuration page for SNMP, and pull those community strings, because we can typically take those community strings back into the network and attack other devices on the network. An example of the attack would be, we find a company that is very big on using SNMP to enable all the devices or manage all the devices on their network. Turns out that they even put them on their cameras. We have a couple occurrences of this during assessments I've done. So they've enabled SNMP on their cameras so they can manage all their cameras. But one thing they fail to do is change the default passwords on these network cameras. We always seem to find one or two on every large environment. So we can log onto the camera, go to the SNMP page, pull the SNMP configurations out of the configs on the page, turn around and replay those against all the Cisco devices, because they managed to set the same SNMP community strings on their wireless cameras as they did on their routers, switches, and firewalls. And now we can pull all the running configs off their wireless switches and firewalls and get that type of data. So that's kind of the attack vector there. So as I'm going through this, if you have any questions, any input, don't hesitate to, throw it in there.
So you see SNMP strings being shared a lot?
What's that now?
You see a lot of SNMP strings being shared or reused a lot?
Every company, I've never seen them different. Now, there'll be different between the public and private, but I have yet to find a case where they're set differently. Normally, when I find those, I sit down with the customer and go, okay, SNMP is cool. You need to use it. It's a great management tool, but set security levels. A Cisco router is at a different security level than an IP camera. Okay, you need to take that into consideration. That's like hiring an employee, and on his first day, you go, Bob, here's your username. Oh yeah, and here's your password. And that same password is the same password you use for all the domain admins in the company. It's that same philosophy. You wouldn't do that. You shouldn't do that with your SNMP. The public-private community strings should be considered just like passwords. So Praeda, from a structural standpoint, has three key pieces. It has a main dispatcher program. What that dispatcher program does, it takes input. The input you can feed into it is a CIDR, like 192.168.0.0/24, and it'll actually crawl that. You do that in a port like port 80 or 443. You can also feed into it an actual target list, so you have a file that contains all your IPs that you want to check. Feed that into it, or you can feed the output from Nmap into it. So you run an Nmap, and you get a GNMap output. You can input that straight into Praeda. It'll identify all the devices, all of the ports that have certain HTTP, HTTPS enabled. And what it does is it goes through and does the fingerprinting, the title page, the server type, and the SNMP. And if it has a match within the target list database or the data file list that it has a match for that particular device, it'll go ahead and it'll call individual modules. So we try to structure this thing like a framework, so you can write different modules. And there's a number of reasons why I did that. I hate to have a program that has all this different data and it's all in one big program because it's not manageable. This way it's easy. This main body of the program never changes. You have a data file that you just add a single string to it. It contains the name of the device, the fingerprint data, and the module that needs to be run if it has a hit on it. And then it'll call that module. When it finds it, it'll run it, it'll output the data into a file. Now this is an ongoing project. I've been doing it 4 years. And what I've managed to do in 4 years is never tell anyone it's not a beta. Since I suck at programming, this is a beta program. So we're always looking for ways to improve it.
You just kept moving closer and closer to these people.
Okay. So that's how that particularly works. Okay. And I think we covered that. Scans network embedded systems. So we scan our network. We do that by, I like using a GMAT input. It goes through all these different devices. If it gets a hit on a device, it fires up a separate module, it runs the data and outputs it into a file. And it all does this based on the fingerprinting, the input data, and of course it said it logs all the way. So how we use this, okay? This is kind of interesting. So when I first wrote this tool and started using it, it was the last tool we run on the last day of engagement before we left. Because everyone's going, yeah, you know, what kind of data we get? We had all of our own methods for compromising all the services on the network. Excuse me. So we were slow at getting around using the tool initially. Well, I show up at a company site, and this is when it all changed. So it turned out that every workstation on the network, the administrator account was disabled or was not network accessible. Okay. So if I did compromise an admin account, it wasn't going to work to get anything else. It also turned out that the password was different on every server in their environment. So if I compromised a single server, which we did, we compromised a machine here, a machine there, we weren't able to get any kind of creds to go anywhere else. So that didn't work. They also had some network segmentation. That didn't really play into this. It was against some other isolated systems that were used to control plumbing and stuff for the city. So I'm on this 4-day engagement. I'm day 3, and I've broken into 30 machines, and I'm not domain admin. I don't own everything in the world. So I get down to the last day. I run this program. It finds a printer. It extracts the data, and guess what? That one account they set up on that device was a domain admin account. So if I ran this day 1, I basically had everything to start with, and then the rest of the time would have been playtime. Instead of panic to try to elevate myself in the environment, it would have been fairly quick. So after that, we started running this as the first tool. As soon as I get an INMAP done, GMAT output, I feed it into this tool, and I let it run while I go off and do other hacking. I ran an engagement this last week. I managed to pull username and passwords for Active Directory, even though by the time this was done running, I'd already compromised somebody and done a bunch of other evil stuff. So that wasn't the deal. But yet, we're hitting 40 to 50%. So it's kind of amazing what's sitting out there for the taking. And this tool generally doesn't use a lot of exploits. It uses the functionality of the environment. And by using the functionality of the environment, we're able to fly underneath the radar screen of IDSs and IPS solutions and stuff like that. So it's pretty impactful. You know, the customer's never going to notice because we're doing normal stuff. And we're getting credentials that we can turn around and use like normal users to use that data to gain access to other critical systems in the environment. And Dave Kennedy had mentioned earlier, you know, about that type of thing. You know, it's one thing throwing an exploit, but he's talking about using the normal functionality of the systems, of the devices, of the programs. And that's basically how this works. So then we always get challenged, and I always like to throw this in here, especially when we're dealing with multifunction printers. So how many people in here that work for a company that their first rule before any printer is deployed onto their network, that they're forced to change the default passwords to something complex before it's ever actually deployed? So we have 2 in here. So when did you start doing that? Yeah, you've probably seen my presentation. But people are not doing that. So passwords are rarely an issue dealing with multifunction printers. Now, other embedded devices, yeah, we see more of those actually configured. But if there's a number of them configured, other than, I think, you know, routers and switches, most companies are above deploying those with default creds. But most of the other embedded devices, they may have, you know, 50 or 100 of them on the network, like IP cameras. Inevitably, there's always 1 or 2 where the default creds are still there, which gives you foothold. Same way with things like Liber and APC power control systems, or the management cards that go with APC management cards. Inevitably, there's always at least 1 or 2 that aren't properly configured. And again, we get back to the SNMP thing. If they're a heavy SNMP shop, that 1 or 2 misconfigured cards is going to give me access to be able to pull those SNMP strings in the hardware environment and gain access to various other devices on their network. Any questions? Okay.
Yeah, just one here.
Yes, sir. Okay. Okay, so let's look at this stuff. Let's see if this works okay. Everyone see that okay? See that in the back? Okay. Let me see what I even have in here. Try to spell it right now. So we have Praeda. And just to look at some of the information on the thing, like I said, there was 3 key pieces. There's the dispatcher, which turns out to be the Praeda.pl. Pretty straightforward there. We also have the data file, which is in the data folder, and we have a jobs file. So let's jump over here and look at the data file. This is kind of like the fingerprinting list. It's fairly straightforward. So it starts off, the first pipe delimiting is what I used, is just a numbering system. It means nothing. You can write eat shit in there and it'll work fine. So, so that's just for me to keep track of what I've actually put in there. And then we get into the title page. In this case, it's HP LaserJet CP05. And then we get the server type. So when we get that fingerprint, it's going to call a job called MP0001. Pretty straightforward. So if we come down through here, we see a number of different devices. And a lot of these do weird things. This phaser one, it was some testing we were doing. It actually pulls a clone file off a phaser printer. And if you've seen any of my other presentations, there's ways to extract data out of those that may be usable. We have the Toshiba devices right here, Toshiba, and this is, as you can see, it looks for top access and Toshiba Tech Corp, which is going to cover almost all the models. So some of these fingerprints are ambiguous, and that can be a problem at times because they may have the same fingerprint, but you may see some submodels being produced. When we identify some of those submodels where the attack doesn't work, sometimes we'll convert over to using SNMP for the fingerprinting specifically on printers. And we have a number of Xerox that do various different things, pull address books, Here is some office jet devices that will actually trigger the actual remote pay or the scan on the system. Spill that on my laptop.
Hey, Daryl, just a quick question while you're doing that.
Yes, sir.
Haven't a lot of these manufacturers been kind of joining together, and there's, what, like 2 companies now making all these printers with just different labels on them, different brands?
I see that with the Ricos. The Ricos, and there's the Ricos I know are manufacturing. There's like 3 or 4 weird name companies that I've seen out there that are duplicates of the Rico. They just remade, they redo the splash pages on the web interface, and they put their own decals on the front of it. But yeah, you're seeing some of that take place now. I don't know if Xerox is doing that. I think Xerox is still holding tight to their brand. And I think HP is still holding tight to their brand. But I think Konica, Toshiba, and Ricos, you may see some off-branding taking place with other vendors. So as you can see, we have a number of devices here. Here's a Canon Image Runner Advanced versions, and you can see the different modules we have set up and run. Here's some Canons where we have multiple modules that are actually run that do different things.
So are you calling those modules then?
Yeah, this is the fingerprinting table.
Okay.
This is the table where the comparison is made. So this data is pulled into the main dispatcher program. So when it's going out and hits the IP address and gets that data back, the title page and server, it compares it to this list. And if it gets a match, it runs those programs at the end.
Okay.
You know, right up here.
It's not like an option where it's like, oh, hey, this is a Canon IR 3045. You have these 3 options. It just goes in.
It'll go right through all those 3 and run them. So up here where you see the Canon IR, these are the older image runners.
Gotcha.
And I've written multiple modules for those because I wanted each module to do a different function. I didn't want to write a module that did everything. Because if they change something within their environments in a firmware upgrade and they change the way of doing one thing, I don't want all 3 of my modules to break.
Right.
I'd rather have one of them break, and then we identify and we're able to fix one module. We don't have to fix a program that's crammed full of all kinds of crap that's confusing. So if you look at the modules, which I'll show you in a minute, most of them are fairly simple. Anyone in here could reproduce them themselves. You can look through the modules, and if you have a printer that when you go to the web interface and you can drill down through it and get everything, you can easily take some of these modules that I'll show you here in a minute and basically cut, paste, add your own pieces in them because they're all annotated, they all make sense, and I don't care if you're not a programmer. It's that easy to figure out because it was wrote by somebody who's not a programmer. So you'll get a lot of people griping, try and keep my language decent. You get a lot of people griping about Perl programmers. So any Perl programmer that looks at anything you've written go, you know, I could write that in 1 line of code, kick him in the ass. Because he's going to write 1 line of code that no one's going to understand 6 months down the road. And I hate people that do that. Programming, especially these scriptive languages, need to be descriptive. They don't need to be compressed because the amount of speed you're going to get by doing compressed code in Perl isn't, in my opinion, going to be significant enough to outweigh the fact that no one's going to know what the hell you did 6 months down the road. So that's my bitch at people. I'm done with that now. So then we get in, so now up here we had these ones that started with P. These are all printers. And then we get into these lower modules. A number of these will just check for default creds. Like Riverbed, Celeron devices, Easy Server. Some of these I'm not even sure what the hell they are. But they're various devices we've encountered that are embedded devices. And we go, hey, we got time, let's write a quick module while we're on engagement in case we see these again. It'll automatically tell us if default creds are there. Because when you're on engagement, a large one, where you end up with 1,000 devices, embedded devices on the network, to go in and check the default creds on every device becomes inherently difficult. And of course, you want to share with the customer any kind of security risks that may exist. So the goal here is when we do find devices, we be able to identify, since we can't physically look at every device, let's try through time to start automating as much of it as we can for testing that. So we have a large number of different devices here. And these ones at the bottom are stuff that me and Matt, who's in the back, were working on. And I don't know if you've seen the work we did. Hopefully I get a speaking slot at DerbyCon and people will get to see it. But we'll save that for another time. Let's jump out of here. Any questions about that file there? So let's jump over and look at the job files real quick. And of course it's Perl script, which is...
Daryl?
Yes, sir.
I do have a question.
Yes.
How do you generate that file? Do you do it manually or do you have a tool that generates?
No, you know, I actually, it was kind of funny. I had the guys working with me bitching about that problem. And it was kind of weird. So I do have a program that can automate that, but I never did release it. The one thing that they were griping about was I tell them, look, your own engagement, generate modules. When you find a device that has default creds, write a module, at least check for default creds. We can add other functionality to it later. And they were like, oh man, I don't know how to do this, I don't know how to do that. So typically this is manually generated, that's how I do it. But I did actually write a program that will basically, all you have to do is type in the page of the server, you know, the main logon page. You have to put in the value of what they're assigning username to. You have to put in the value of what you call the password, and then put in the username and password, and run the program. It will, in the IP of the device, it will fingerprint the device, grab that data, and it'll generate that entire string and write a fully functional module to do everything. So basically, so I wrote a Perl script that would do that, and I couldn't get them to use that either, so.
Jesus, but this whole thing beats the hell out of like saving default passwords with this. You have a program, you keep it updated.
Yeah, default password, you know, it'd be nice to actually, keeping a default password list is so difficult because I'd love to be able to do that. I'd love to have them all memorized. I have like most of the printers memorized by now, but.
Yeah, but you don't have to.
Yeah, the whole idea is automated. Plus it saves you from having to go look at every device on the network because you don't have time. I've literally been on sites where they had 10,000 systems and 3,000 to 4,000 of those were printers and embedded devices. So, and engagements, they're time consuming and you're a short period of time to actually do the work. So you don't always get a chance to do this, but my goal has been, when I do have time, to always generate some kind of module. So we're looking at these modules here, and let's look at, let me just bring one of them up. I'm not sure which one this is going to be. Learn how to type. So here happens to be a Minolta. And most of it is just generic data. A lot of the core stuff is brought in from the primary program, so you don't have to do a lot of things. All of these things here never change. So this is just cut and paste type of stuff anytime you want to do anything. Same way with that. That's just output for logging information that what you're looking for. And then the first thing you do here is we were actually validating model types. So what it does is it basically pulls the primary piece of data off the device, which is the fingerprinting, says, hey, it's this model or that model. We set up basic session cookie storage information because it's going to need a cookie as it moves through the program. Pretty straightforward. We enable redirecting. I had some printers that just had like real issues with redirecting type stuff, so that's kind of a redirecting for the post operation. And then we actually do a post. So here we're actually doing a post for the logon, and it's going to call the password, that password field, which is, and this is one of the more complex, here's where the passwords are set for the two different type of models. And I know looking at code's boring, but
Someone is yawning.
yeah, I heard that. I think they're trying to make a point here. Oh, it's code. You're that guy that's not going to run it and run my program or write anything anyway, so feel free to get some sleep. And then what this does is it actually parses LDAP settings on the device. So this here is probably one of the most complex ones. So what this thing does, this program here, and you look at it, it's simple. All we're doing is reproducing what you would do from a keyboard in Perl. Your login process, your post, your get. We're taking the output, we're parsing it, we're putting it in a file. Pretty straightforward. Every structure in every one of these Perl programs is annotated, okay? It tells you what the next block does. This is one of the more well, not one of the most complex ones. We have some fairly complex ones that do SOAP messaging attacks. We have one, I have a cool one in here. It's like really cool. So anyone ever see my firmware attack work that I did against Xerox? So one of the big things is there's ways to reproduce Xerox's firmware process using firmwares or Xerox's own tools. It's just totally cool shit. And actually get a reverse shell on the device with root level privileges. Really simple, trivial. I wrote a paper on this out there. But one of the things we ran into is, well, what happens if I hit a Xerox printer, someone's changed the password on it? I'm freaking screwed. Well, no, because I can send a firmware attack to the thing. And all you do is send this job to the port 9100, so it's unauthenticated. So we actually have a module in here that what it does is, it is actually a firmware bootstrap program that's sent to port 9100, and what port 9100, when it processes the data, it executes a shell script on the system. It goes to a specific admin config file, which is the only thing on the device that's not encrypted, only password, and that's the console password. It pulls the set password out and writes to the root of the web server in a file called Praeda.txt. Then the program retrieves it and then sends another firmware attack to the device to actually delete the file. So, and the reason why we have to go through all those steps is we don't have control of the IP address. We can't write into the firmware package the IP address we're coming from dynamically because it has to be signed with proprietary information, so I had to pre-build it. So it was easy enough to pre-build the injection attack so that it's actually just writes the file so more locally that it's retrievable through the web interface. So I don't want to run out of time here, ramble on. So I think, does anyone have any questions about Praeda's structure and how basically how it works? Anyone confused? I'm actually going to present part of this stuff because I'm actually speaking at Black Hat Arsenal. At Black Hat, I'm talking about Praeda. So some of this stuff I'm bouncing off you, and so it's important to get feedback. So if you go, Deral, you just confused the hell out of me, you're not going to hurt my feelings. So I get to prove it. Yeah, and when you run the tool, I mean, it's Praeda Perl. So there's a command structure. It's basically 3 to 4 pieces of information you put in from the command line. Straightforward. And what it does is it outputs. Let's go ahead. In this case here, let's say we did a GMAP file containing data. We said the project would be sample 1 and the output log file would be, let's go to sample 1 because I don't remember what I wrote in there. So the output would be group 1. So it'll create 2 files. One's called group1.log and one's called group1.webhost. Now this should be clean data, and if it's not, everyone close their eyes if it's not. That would be stupid. So these are the 2 things that are output. Did I just type in log? Yeah, I typed in log. Okay, so this is actually a real output from like only a few days ago. From an assessment. And as you see, we actually got our hands on an S&P community string from an APC device. That this particular one only worked on all the other APC devices. In their case, they weren't using S&P in their Cisco environment. And this was old legacy stuff. So, but it gave, and this was the only APC device that did not have the password set properly. So what is the password for an APC device?
APC, I thought.
Default password for APC.
Oh, it's APC.
APC, there you go. Now everyone knows it. It's pretty simple, straightforward.
I can kind of like UPSs from them.
Yeah, that and Lieber's another big one.
We'll just leave it.
Yeah, Lieber, it's the same way, ABC, it's pretty straightforward. Both of you can steal SMP community strings off of it, configure it. So I love these devices, because there's always at least one out there that's not configured properly. And of course, here we have cameras, Falco series camera devices. And it turned out that half of their devices had no community string set. As you can see, we tried to strip the community string off of them, so that kind of sucked. Okay, so that didn't really work. But we were able to identify all the devices that had default creds. And I've been working on cleaning this up. So, I mean, this doesn't look easily parsable, but if you just grep this file for the word success, you'll get all the permanent data, typically. Don't get the public thing. So I'm trying to clean up some of the output. It's been taking me a while so that it's quickly parsable. Because one of my biggest complaints is there's a lot of cool tools out there. And if you go into like Kali and look at all the tools that people have written, almost the outputs from 90% of the tools are totally worthless for parsing. So if I use the tool against one system, I'm fine. But if I use the tool against 10,000 systems, I'm screwed. There's no way I can parse any of it to usable. I have to write my own parsers, which is my biggest complaint. So usually I just get pissed off and rewrite the whole program myself to do it the way I want it to work.
Hey, Daryl, is Praeda already in Cali? Does it ship with it?
Nope.
Leading edge or anything like that?
Nope.
Okay.
So as you can see here, we got all these devices. So then we get down to the, where was it?
Does it have any dependencies besides just having Perl on the system?
Well, I'll show the Perl dependencies. Yeah, there are some Perl. Dang, I thought I had that in here. I thought one of these had it in here. Hold on. Oh, for some reason it got parsed out of there. But as you can see, it attempted a password extract. This particular module carries out an attack, which is known as a capture LDAP. It's a passback attack. So what it does is, for some reason, I removed this and was going to change it because it did return data, but the data was proprietary information, would identify the person, so I cleaned it out. And I was going to put bogus data in there, show you generally what it would look like. Because it contains some binary garbage in there too. But basically, what it is an automated passback attack against sharp printers. And the way a passback attack works is it'll actually log onto the printer. It'll go to the LDAP configuration page. It'll change the IP address of the LDAP server to point back to itself. It'll next tell the printer to do an LDAP lookup in plain text, capture the password, username and passwords for LDAP authentication, and then change the password back. But the Sharp actually doesn't have to change the password. It can set the password without permanently writing it in there because there's a test function. So it kind of automates, kind of like you go to the printer and say, hey, tell me what your LDAP settings are. And the reason why, the cool thing about this whole thing here, the reason why this functions the way it was because crap I did 4 years ago. So 4 years ago, I hit a bunch of the printer companies with the fact that you could go to the settings on the page, the LDAP settings on the page, and if you looked at the source, you would find the password stored in the web source. So I did this at ShmooCon, and they were like, I pissed off a half dozen of them, and all at once they all changed. So now the actual printer or the passwords are stored on the device, no longer in the source. And to change it, you have to check a button before you can even change the password. But they screwed up. Everything else on the page can be changed without altering the password. So now all I have to do is alter the printer to say, hey, your LDAP server's not that one anymore, it's me. And it'll be nice enough to try to authenticate with the password that's stored in the system and send it to me. You got to watch though. You got to set the device to plain text because there's like Kerberos and NTLM thing and SSL, and you just got to shut those things off. And then go, yeah, do a check. And of course, the printer will come back and say failed, but then all you do is fire up Netcat and you capture it in plain text. The Sharp will actually show up. The username will be fairly easy to read. If you cut and paste it into text, it'll get rid of some of the weird binary, but you have to strip the 0B off. There's a 0B that shows up at the closing end of the password, and that's not part of the password. I'm like a third of the way through this presentation, so. Okay, if, the other thing I want to show is this, group web host. Oh gosh, that was the wrong one. I must have overwrote it by accident doing something wrong, because I think this is.
It's dot log, not dash.
Yeah. Yeah, unfortunately, the web host one's incorrect, so I inadvertently overwrote this stuff. And I think this is the one I cleaned up. So you can see how the password shows up there. That's how it will actually show up. There may be a little weird binary at the beginning sometimes, but that 0B will have to be stripped off. The other program that I inadvertently at 1 o'clock last night overwrote with the wrong file, the group 1 web host will contain all the fingerprint data. Unfortunately, this one doesn't because I inadvertently overwrote it for some stupid reason. But it'll contain all that fingerprint data. It'll contain the IP address. It'll contain the server type. It'll contain the title page, and it'll also contain all the SNMP data that pulled off the device. So even though you didn't attack a device and there was no tool for it, you could literally go through and visually look through quickly and identify devices that you may want to look at as a pen tester. I know there's tools out there that'll do screenshots of like the websites. Those are kind of cool, but this is also a quick way. You already have some data to do a quick analysis. And you can find devices that you want to look at further and do some other cool stuff with. So, let's see if we can move forward here. Yeah, PraedaSploit. So how many people here don't know what PraedaSploit is? Okay. So PraedaSploit is a key tool for all pen testers. It's basically a tool that contains ongoing development of vulnerability attacks that you can carry out to validate whether vulnerabilities actually exist or they can be exploited or exploit them. So you can use this tool to take control of vulnerable systems and do various things. So this tool was written by H.D. Moore and his guys in 2003, and then and that was written in Perl, and then in 2007 they rewrote the whole thing to run in Ruby. And currently there's literally everybody on the face of the earth is actually using this tool for pen testing. Almost everybody does. PraedaSploit project was purchased by Rapid7, who I work for. There is still a PraedaSploit open source version that's continuing to be supported and will always be supported. It's the framework. There is a pro version that is available, a professional version that you can get from them. It has a lot of other horns and whistles and functionalities and stuff. But generally, they're fairly close to being the same thing from the framework standpoint. So what I'm in the process of doing is I'm going to migrate a large portion of Praeda, the modules, over to PraedaSploit. There's a number of reasons for going with that model. And they're listed here. It's easier to maintain because we're dealing with a project, the PraedaSploit project, which has a large amount of involvement. PraedaSploit can also be used, the captured data that you pull from these devices can be used in other attack vectors and scenarios, like passwords. If you pull the passwords and you eventually get those passwords into the device, it can be used to automate attacks to other systems. So you have this full functionality. Plus, this is the big thing, large community base. PraedaSploit has over 200,000 people that are involved in supporting that product around the world. So it gives us stability. The problem with Praeda is nice. I wrote almost every one of the modules. And trying to get people involved in that project was very difficult. I had a couple people throw some help in there, but generally it's been a small audience of people. And that's why after 4 years I can only do 100 or so devices. If I move it over here and start down that road, getting other people involved saying, hey, here's an attack vector, let's build from there, we can bring that amount of functionality up significantly. Any questions? So to start this project, me and a coworker had been working on migrating modules over. And we've done a total of 7 modules have been written so far. And these include Xerox LDAT passback module, okay? Also a Konica address password extract module, Canon address book extract module, and some Dell HP username extract modules. There's about 7 or 8 of these. The other one that's not listed up here is the Xerox password attack. It does a firmware attack. That's been written. That's available out there.
Are these live?
They can be pulled down. They're beta right now, and at the end I'll show you where you can download these from.
Okay.
And I'll show you how to, if you haven't used PraedaSploit, or how to put stuff in a repository on PraedaSploit that won't get overwritten every time you update. I'll show you how to do that here in a minute if I have time. Let's speed through this. So here's a couple examples of these. These were actually tested. So here happens to be one of the HP modules. And the goal of this one is pulling address books. Or pulling usernames. Turns out a lot of the lower end printers, at least the lower end color printers, support a chargeback functionality. So they keep very detailed color logs for chargeback, and this includes your Active Directory usernames. So if you're in a Windows environment, anytime you use one of these printers, it's going to actually write your username into this log, okay? So we're able to pull those usernames, and this is an example of it running, which can come in handy for brute forcing during assessments or whatever. I actually have errors pointing at it. It's all fancy crap. So the Canon pulls the address books, and it'll pull the entire address books and save it. The big thing with the Canon advanced versions, the key thing is just you logging on and pulling the address books is not going to get the passwords. You have to log on, check a box that says export passwords, and then you have to export the passwords. But they're all encrypted. Unless you know that the post process that makes the request is flawed with an ENC mode setting, that if you set it from the normal 2 to 0, it'll actually output everything unencrypted. So we automate all that here. So as an example, you can see we're actually able to pull the address book and unencrypt the actual passwords, have it unencrypted before it sends them to us. So we're automating that. And Praeda does all this too, but here we're making it available in PraedaSploit. Here is the Konica. This one will actually do SOAP messaging requests against the device, and it pulls various usernames. In this case, it is a FTP password that's being pulled off the device for FTP services, but it'll pull FTP, SMTP, and SMB passwords out of the address book functionality on the device. So we've automated that. And right now we have them all set up to actually save this data. I think this shows it right there, credential save. So it'll save them all out into a loot file. Here is extract admin password from Xerox. This is a firmware attack. It'll actually go out there and pull the password. That happens to be the default for most work centers. This attack doesn't work on the new stuff. Xerox kind of like fixed it when I told them, which is what I expect. But I haven't got around to looking at the new ones, but I assure you, as soon as I do, we will fix that problem. And I'm sure I'll be able to get these passwords because I know how I can do it already. I just haven't had a chance to test it. So, demo how to install the beta. So let's look at this real quick. I think I was going to put this at the end. Let's jump to the end real quick. I want you guys to get that stuff. This right here is where the modules are available. Right here, GitHub, Moose Dojo, PraedaSploit. You can get all the new Metasploit modules, okay? And this is where you can download Praeda. Let's jump back up here. So in this case here, we want to load up a module. So we go use, I'm hoping this is in there, something like that. Scanner, Praeda. So we can see all the modules, and there's some, I do development on this box also, so you see some weird stuff there. But as you can see, Aux, Scanner, Praeda, they show up. But literally in the core system, my Praeda Pro or framework, they're not there. They're not in that standard folder. They're in another folder. Oh, sorry about that. Let's bring that up a little bit. There we go. And where they're at is, the best way to do it is if you come along and you go modules. This is in your home drive on your system. You create these folders. There'll be a .msf4 there. You go in there and create these auxiliary, scanner, in this case, Praeda. And we create this folder just like this here. We can download all of those and put them in this folder here. And then when you reload PraedaSploit up, they'll be available under that standard Aux, Scanner, Praeda folder function. That way, when you update or make changes to Metasploit, these will not get overwritten. And then once they're available in the core system, then you can take them out of here. Yes? Well, you can do a git clone, but you're not going to get these modules because they're not in Metasploit.
No.
If you put them in here, yeah. Yeah, I was just showing you where to put them. You know, yeah, you can do that if you want. Yeah, that'll work fine. So you can git clone into this folder. You'll have to be root on this, but if you're doing it from a Kali, then that's not a problem. But if you're not on Kali, just make sure your root. And these are, and I also suggest if you're out there and you're looking at some of the stuff we're doing and you want to get involved in this project, please do. Give me a holler. I'll help you out ever how I can. Praeda, the main Praeda program is not going to go away for at least a year. It'll take that long before we get everything written, so it's going to continue to be supported. Here, let me bring this up here.
Hey, Daryl, real quick, you
Yes.
said that you have to be root on there for what purpose?
Well, this folder, the .msf4 folder.
Isn't
Yeah.
that just in your local home directory?
Yeah, but when it's created, when you install Metasploit, you don't install it as, if you try to install Metasploit and not do it as root, I don't even know if you can you? I've never been able to. Have
I've
you?
done it before.
Yeah, I wouldn't know. In this case here, this is pro for me. So this had to be root to actually get it all installed.
That might be
But whatever, I would check it out. If you could write to this without being root, then that's fine.
Yeah, because the .msf4 should just be in your local home directory.
It is, but when you create the install of Metasploit, it's going to, how you create it Metasploit, then that's how it's going to do it.
I don't think you have to be root to install it, but I think you have to be root to update it for things to reach out.
Yeah, there's so many fingers in the various things. It's easier I just installed everything as root, and that way I didn't run into problems when I'm dealing with the Postgres database stuff. Because if you install it not as root, then you run into problems with Postgres, getting Postgres to automatically start up and a lot of issues. But most people run the framework just off Kali, and Kali's root, so you're not going to run into any issues in that case there. Yes?
Now, you said with all C files to be able to run all these at one time against the same set, and also can you pull in Nmap into the database and then, based who you want to scan based on like who has port 80 open?
Those are the things that we're going to be working on. So currently right now, Metasploit is not a global vuln scanning tool. You cannot say scan the entire network and carry out exploits or run modules. It won't do that.
So right now, if I want to try for I don't know what kind of printer something is. If I want to try every one of these modules, I have to do them individually or throw them all into one big all C file?
That's the current state of Metasploit.
Okay.
We're going to go there.
But Praeda's going to be around for a little bit, so Praeda does it.
Yeah, it
Tries all these.
does everything right
Or
now.
everything looks like it's valid based on like headers and such.
Right, exactly it. So let me go ahead and finish up the presentation, because we're going to touch on that. That's where we're going to go. So PraedaSploit, Metasploit, PraedaSploit. Screw them together real hard, you get that. So like I said, we're migrating all the modules over to Metasploit from Praeda. That's the goal. We got 8. Some of them will get thrown away because they're old, not as usable anymore. We're going to generate new ones. There's stuff already existing in Metasploit, all within our model that we're already looking for. Our goal is to create a new Praeda. Now, it won't contain none of the modules, but its purpose is to function as that scanner. Okay, so what we want to do with the new Praeda is we want to improve fingerprinting of embedded devices and have a higher accuracy rate. We want the ability to call Metasploit modules. Now, how we're going to do that, we haven't hashed that out yet, because from what I understand, the design within Metasploit is not for it to be a scanner, automated scanner. So writing a module that they're going to let us put into the core product that turns it into a scanner may not happen. But we're considering the options, and we haven't talked to the powers that be yet. So what we want to do is we want to be able to call these Metasploit modules. We want to do what you said. We want to scan the environment somehow, fingerprint the devices that actually matter to us, and then what we want to do is call the appropriate Metasploit module. So we may run this as a standard Metasploit extension, like incognito or something, if we can get it embedded in there, or some other functionality. And there's a possibility it may be completely standalone and just API handle transactions with Metasploit. We haven't hashed out those details yet, but it's in the works. We're kind of working on that. Yes?
The browser auto kind of function is still there, so what you could do is hold DB nmap and then compare your nmap results to your bank.
Right, yeah, well, in that case there, yeah, Autopone's there. Autopone's not a very accepted function.
The browser auto function, the old one they got rid of, but it's still available under.
So I'm not into running Autopone, and I would never recommend that. So we're not exploiting any device. The goal is not to exploit any devices. So we don't want Praeda actually carrying out what we consider exploits. It's one thing. There are a few exploits that take place in there, sort of, kind of, but generally it's an information gathering tool. So we only want to do that. So yeah, I know what you're saying, but you're talking about major change or rewrite of Metasploit. They may not allow that. I can assure you the whole Autopone thing in the general product is in that functionality is not going to be
I'm just
supported.
using that as an example of
Right, true.
module that you can compare nmap results to execute it.
Right, but nmap's not sufficient enough to carry out these attacks. It's not sufficient data. Nmap doesn't, even nmap fingerprinting is not necessarily sufficient data. Also, and I'll be the first one, I don't like nmap being ran from Metasploit. I know some people do that. Because you end up with everything in Metasploit, and then there's a lot of cool data that's parsable, that's usable in other places. That's a bitch to get out of Metasploit once it's in there. I like running nmap by itself, and then if you want it in Metasploit, you endpoint the XML. You do an all run on the, not all run, but a -OA run on nmap, and then output the XML. Because I like GMap output, I like standard nmap output. I have something I do with all 3 of them, so I usually try to keep some of that stuff separate. But yeah, I understand where you're going at. So those whole things are being thought out.
And there's something else, and I'll share with you later if you're interested, where it takes fingerprinting to a whole new level. So your accuracy will increase by like 2-fold at least.
Yeah, we've been looking at a number of things. There's also a Ruby fingerprinting tool that HD Moore was part of not too long ago. Framework that already exists out there that we've considered possibly leveraging it or building Praeda around that. So yeah, shoot me an email. If you have any thoughts on that subject, shoot me an email. We'll go ahead, because I'm open to any thoughts on the entire subject. So So our goal is additional Metasploit modules. We want to build out more Metasploit modules, get all this stuff done, get it all migrated over. An embedded scanning engine, fingerprint embedded devices, the ability to call Metasploit modules. These things that haven't been done yet, this is what we're thinking. And we've been brainstorming on it, so we have some ideas, we have some thoughts, but we're not there yet. We haven't jumped off that bridge. Our goal is to get as many of the modules that we've developed in Praeda over to Metasploit. Once we get a large chunk of stuff over there, then we'll start looking at, okay, how do we interact with Metasploit? How do we build a scanner? Can we build a scanner that they'll let us put in Metasploit to do this? So my ultimate goal would be able to, in Metasploit, you would just type in Praeda and take the InMap data that's there, or some other data that, or have its ability to do fingerprinting that way, or have its ability to take the InMap that's ran and import some of that functionality that you see in GMap type things that work.
In current version of Praeda, though, instead of giving it a site notation list, can you give it like InMap or IP list and say only check the ones like, I'm assuming by default, what does Praeda check, port 80?
No, you have to tell it what port. And
Okay.
the two functions you have to tell it what port. If you put a CIDR in, you need to say 80. If you put in an IP list, a file list, you have to put in the port 80.443, whatever the case. But if you use GMap output, you just reference the GMap file. It'll automatically, GMap contains all that data.
So if it has HTTP as a possible, it'll check it out.
Yes, it will.
Oh, awesome.
Yep. The only issue with that is there's some really bizarre ports that exist out there that InMap will say is HTTP. And it plays hell on Praeda, because what it does is it'll establish a connection and give it the connection, but then won't let it time out. It'll hold it, so it'll stop running. Those are rare, but I've run into those a few times. And I was going to write an exclusion in there for it, but I haven't quite figured out exactly. There's a couple of them. And I don't count on that often, but once in a while when I hit very large organizations that have like 8, 9, 10,000 machines, I usually end up finding 1 or 2 of those in there, and it totally freaking screws you up.
Yeah, I've learned a lot of embedded devices that, being able to find the passwords quicker without having to do Googling it myself, or for a lot of them to be useful.
So the ultimate goal is to write all these in there. If you're on assessments and you find a device, and they all have web interfaces, and it takes the default password, once you find that default password, look at the Perl that we've written for Praeda, or look at Metasploit modules, and look at, let's start writing modules to do that. Let's kind of automate this functionality. For anyone here who does this type of work, let's kind of like work together to make our jobs all that much more freaking easier, at least for data gathering. Now, that's the ultimate goal. I'm lazy. Hell yeah, I'm lazy. I don't want to look at those devices. I can think of a lot more funner things to play with when I'm on assessment than have to check for default creds manually on a bunch of freaking devices. So I hope you found that entertaining, enlightening. You didn't throw nothing at me, so I guess that counts for something. Or are you going to save it till the end?
When do you think the migration will be done?
I guess it depends on how many people start helping.
The migration, I don't know. I'm always juggling 40 billion projects, and this is kind of like an extended project, an actually sanctioned Rapid7 extended project to migrate that stuff over. Because I get like, I can't remember what to say. But it makes some better opportunities for me, so we get as a sanctioned project, not work sanctioned, but after work sanctioned project. So my goal is I'd like to have it all done, all the cool key modules moved over by the end of the year. I don't expect that there'll be a PraedaSploit, the scanning engine functionality, probably until next year, mid next year or later is what I'm expecting. Because, I like juggling 14 balls at the same time, you know how that goes. And I can only, there's only so many nights I can stay up to 3 in the morning to write stuff. And most of these were written at 2 in the morning. So that's usually what I do on Friday and Saturday night, stay up to 3 in the morning. And I don't write code. I stay up at 3 in the morning and Google code.
That's what smart people do.
That's it. look at other people's code, and then when I'm stumped, I ask my friends, how come this isn't working? And then they get stumped and they ask their friends. Eventually, we ask enough friends and we get the answer.
There's probably one guy in the world that writes code.
Oh, we ran into some real quirky things with some of these modules we were trying to do. Because if you look at most Metasploit modules, what do? They carry out one function, it's the one port. But I have, one of my modules goes to several different ports that actually carry out all of its functionality. And there was no solution existing to make that work. So that was kind of interesting. So that was my presentation. I hope you enjoyed it.
Yes.
And what you speak next? I'm going to listen to you before you cake.
So we'll take about 10 more minutes. He's about